Welcome to the lecture on complex analysis, probability and statistical methods. So in this lecture also I am going to discuss about few more examples based on the construction of analytical functions and also few standard problems. Example, find the analytic function f of z is equal to u plus iv given u minus v is equal to e power x cos y minus sin y. So first let me consider u minus v is equal to e power x of cos y minus sin y. So I'm going to differentiate this equation with respect to x partially. So I'll get ux minus vx is equal to e power x cos y minus sin y. Call this one as equation number 1. Similarly, differentiating the same equation with respect to y again partially, I'll be getting uy minus vy is equal to e power x minus sin y minus cos y. Call this one as equation number 2. So now to find the values of u and v, so I'm going to do like I'm going to convert this uy and vi in terms of ux and vx by using CR equations. So let me replace from CR equations we have ux is equal to vy and vx is equal to minus uy. I'm going to replace this value in the equation number 2. I'll be getting minus vx minus ux is equal to minus of e power x sin y plus cos y. So I can write this one as ux plus vx is equal to e power x sin y plus cos y. Call this one as equation number 3. So now solving this equation number 2 and 1 and 3, I'll be getting ux minus vx is equal to e power x cos y minus e power x sin y. Ux plus vx is equal to e power x cos y plus e power x sin y. So on simplifying this, I'll be getting what? This ux gets cancelled. I got minus 2vx is equal to 2 e power x sin y. I got vx is equal to e power x sin y. So once we got the value of vx, we can easily estimate the value of ux also. I'm going to replace this vx value either in equation number 3 or equation number 1 so that I can easily estimate the value of ux. So from one equation, I'll be having ux minus e power x sin y is equal to e power x cos y minus e power x sin y. So on simplifying this, I'll be getting ux is equal to e power x cos y. So once we got the value of ux and vx, take the formula f dash of z is equal to ux plus ivx. Replace the value of ux and vx here. I'll be getting ux cos y plus I into e power x sin y. So putting x is equal to z, y is equal to 0, I'll be getting f dash of z is equal to e power z. So now to find the analytical function f of z, I'm going to integrate this function with respect to z. So what I will get? On integration with respect to z, I'll get f of z is equal to integration of e power z plus dz plus constant c. I'll be getting f of z is equal to e power z plus c. One more example, if f of z is a regular function of z, show that dou by dou x of modulus of f of z whole square plus dou by dou y of mod of f of z whole square will be equal to mod of f dash of z whole square. So to prove this, so they have given like f of z is equal to u plus iv is regular function. So I'll be taking modulus on both the sides. So in the problem contains in terms of modulus, I'll be applying modulus here. So modulus of f of z is equal to, I'll be getting what? Square root of u square plus v square. I will consider this one as pi. So now I want to prove that, so if this modulus of f of z is pi, I want to prove that dou pi by dou x whole square plus dou pi by dou y whole square is equal to mod of f dash of z whole square. I need to prove here, right? So it is nothing but pi x whole square plus pi y whole square is equal to mod of f dash of z whole square. So let me consider pi is equal to square root of u square plus v square. It will be equal to what? Pi square is equal to, I can write like u square plus v square. Call this one as equation number 1. So differentiating this equation with respect to x, I will be getting 2 times of pi into pi x is equal to 2u ux plus 2v vx. Call this one as equation number 2. Again differentiating the equation number 1 with respect to y, I'll be getting 2 pi into pi y is equal to 2u uy plus 2v vy. Call this one as equation number 3. This can be work. Now what I will do means, so since I need to find the values of like pi x square and pi y square, I'm going to square and add the equation number 2 and 3. So on squaring and adding the equation number 2 and 3, I'll be getting 4 pi square pi x whole square plus 4 pi square pi y whole square is equal to 2u ux plus 2v vx whole square plus 2u uy plus 2v vy whole square. So I can take 4 pi square common factor. I'll be getting what? Pi x whole square plus pi y whole square is equal to 4 times of u square ux square plus v square vx square plus 2 times of uv into ux vx, and u square plus uy square plus v square vy square plus 2uv uy vy. This can be obtained by using the a plus b whole square formula. So from the CR equation, I can convert all the ux variable in terms of vy and vx in terms of minus uy. So I'm going to incorporate these values. I'm going to replace this uy as minus vx and this vy as ux, and same thing here also. So I'll be getting what? 4 pi square pi x whole square plus pi y whole square is equal to 4 times of u square ux square plus v square vx square plus 2uv ux vx plus u square minus of vx whole square plus v square vx square ux square minus 2 times of uv into ux uv. So I can cancel 2 times of uv ux vx with this equation, and also I can cancel 4 also. So I'll be getting what now? Pi square into I'll be getting a 4 pi square into pi x square pi y square will be equal to what? I can take the u square common factor there. So I'll be getting u square into ux square plus vx square plus v square into ux square plus vx square. I'll be having 4 pi square pi x square plus pi y square is equal to 4 times of u square plus v square ux square plus vx square. So on simplifying this, I'll be getting what? This pi is nothing but actually what? Pi is nothing but square root of u square plus v square. Then obviously pi square will be u square plus v square. So I can cancel this 4 pi square with 4 pi square here. So I'll be getting what? Pi x square plus pi y square is equal to ux square plus vx square wholes. So now we have considered f dash of z here. So f dash of z is equal to, I'm having ux plus ivx. So applying the mod on both sides, I'll be having mod of f dash of z is equal to square root of ux square plus vx square. So I'll be having mod of f dash of z whole square will be equal to ux square plus vx square. So I can replace this one as modulus of f dash of z whole square. So I'll be getting pi x square plus pi y square is equal to mod of f dash of z whole square. It implies dou by dou x of mod of f of z whole square plus dou by dou y of mod of f of z whole square is equal to mod of f dash of z whole square. One more example, if pi of x comma y is a differentiable function and f of z is equal to u of x comma y plus I into v of x comma y is a regular function, show that dou pi by dou x whole square plus dou pi by dou y whole square is equal to dou pi by dou u whole square plus dou pi by dou v whole square into modulus of f dash of z whole square. So first, let me consider that pi is a composite function. So treating pi to be a function of u and v, and u by u and v be a function of x and y, to show that this one. So from the chain rule, we are having what the formula like dou pi by dou x is equal to dou pi by dou u by dou x, dou pi by dou v by dou x. It will be equal to what? Pi x is equal to pi u ux plus pi v u px we can write it. Similarly, dou pi by dou y can be written as dou pi by dou u by dou y plus dou pi by dou v by dou u. It can be written like pi y is equal to pi u uy plus pi v vy. So since the equation given like dou pi by dou x whole square plus dou pi by dou y whole square, I am going to square and add both the equations. So I will be getting what? Pi x square plus pi y square, pi u ux plus pi v vx whole square plus pi u uy plus pi v vy whole square I will be getting. So on expanding this by using a plus b whole square formula, I will be getting pi x square plus pi y square is equal to pi u square ux square plus pi v square vx square plus 2 times of pi u ux pi v vx plus pi u square uy square plus pi v square vy square plus 2 times of pi u vuy pi v vy. So from CR equation, I am going to convert this uy vy in terms of ux and vx. So I will be getting what now? Pi u square ux square plus pi v square vx square plus 2 times of pi u ux pi v vx plus pi u square minus vx whole square plus pi v square ux whole square minus 2 times of pi u ux pi v vx. I got it. I can cancel 2 times of pi u ux pi v vx with minus 2 times of pi u ux pi v vx. So I'll be getting what? Pi u square, I can take common factor outside. So I'll be getting ux square plus vx square plus pi v square into ux square plus vx square. I'll be having pi x square plus pi v square pi y square is equal to pi u square plus pi v square into ux square plus vx square. So next, consider f dash of the equation. It is given by what? Ux plus I vx. So applying the modulus on both the sides, I'll be getting mod of f dash of z is equal to square root of ux square plus vx square, or mod of f dash of z whole square is equal to ux square plus vx square. Call this one as equation number 2. I am going to replace this equation number 2 in the equation number 1 so that I can get the value pi x square plus pi y square is equal to pi u whole square plus pi v whole square into mod of f dash of z whole square, or we can write this one as dou pi by dou x whole square plus dou pi by dou y whole square is equal to dou pi by dou u whole square plus dou pi by dou v whole square into modulus of f dash of z whole square. Thank you.